very pleased to introduce Cynthia Albright and Stephen Oliver, who are going to be sharing with us about data-driven transit service and infrastructure planning. Cynthia Albright is based in Reno, Nevada, and she's a senior principal in planning and urban design at Stantec. She has over 30 years of experience managing award-winning projects and has built a reputation as a cutting-edge urban planner and designer. And she was even recently inducted into the College of Fellows of the American Institute of Certified Planners, which is quite a feat. So kudos to you, Cynthia, on that. She's very well versed in strategy, policy, development, and applications that impact the transportation arena. And she recently successfully managed the comprehensive multimodal transportation plan for the Lake Tahoe Basin that encompasses 5 counties, 1 city, 2 state DOTs, 2 state land management agencies, and 3 federal land management agencies. I hope she'll be telling us more about that project because it's a really interesting one, and I think you folks would be interested in it as well. So thank you very much, Cynthia, for joining us. I'll introduce Stephen as well, and then Cynthia, I'll pass it over to you. Stephen Oliver is a transportation and land use planner based here in Calgary, and he's focused on transportation planning, public engagement, urban planning, and project management. Stephen aims to create great cities that serve everyone. He believes the public good involves everyone, and providing the opportunity for contribution through meaningful stakeholder engagement creates enthusiasm, energy, and connections needed for great public spaces. Thank you, Stephen, and thank you, Cynthia, for participating today. And Cynthia, I will pass it over to you to share your screen and take us through your presentation now.
Okay, thank you. Let's see. Give me 1 second. Tell me when everybody can see it.
Yes, looks good. Thank you, Cynthia.
Okay. All right. Well, thank you, everybody, for participating, and I hope you'll find the next 30 minutes certainly worth the time. And thank you, Josh, for the tremendously graceful introduction. So today we're going to talk about the different types of data and how we use this data in order to improve our transportation outcomes. I have 5 different projects that I'm going to talk about really quickly. One of them is the Lake Tahoe Inter and Interregional Multi-Mobility Plan. We have a citywide master plan for transit. I want to show you a time series visualization for just a specific whiteout game, an aerial transportation feasibility study, and then quickly talk about a new project we just got underway, a Trans Mountain expansion project between Edmonton and Vancouver. So talking about Lake Tahoe, this is a view of Lake Tahoe, and in case any of you have never been here, it's one of the most beautiful places on the earth. It's the 2nd largest open freshwater lake in the world, and we are constrained by our transportation network here because of the environment. We can't build our way out of the congestion that the visitors create. We have only 55,000 full-time residents here and a 2-way roadway network that's managed by either the Caltrans DOT or the Nevada DOT. So we were hired to create a multi-mobility master plan. And this graphic just shows you how complicated it is when you have a study area involving multiple jurisdictions that Josh read out in the introduction. The lake is divided by 2 states, 5 counties, and everybody has an impression of what the transportation solution should look like and how their individual jurisdictions intend to manage those improvements. The important point, though, is when you have a project study area of this size, you can almost certainly count on not having high-quality data that is combined and compiled in the same way. And that's why and how we convinced our client to invest in location-based services data, because we could buy it all for the entire study area and use it to analyze how the population moves and how best to make recommendations to address that congestion. These are some of the images of the various activities that you can do in Lake Tahoe, and I hope you'll agree that it really is quite spectacular. I only live 25 minutes from the lake, and so we're up here all the time hiking and certainly snow skiing, running on the trails, and visiting the beaches. The important point is that our client was under the impression, based on traditional visitor counting metrics, that their annual visitors were only 8 to 10 million, and we used location-based data to show that that number was significantly lower than what it really is. When you buy location-based services data, in case none of you have in the past, I'm sure you've all heard of Streetlight. Many of you probably even use it. What you want to do is buy the data aggregated to some form of geography that you can bring into your traditional travel demand models. And so TAZs are what we used. There's over 300 of them in the Tahoe Basin. And then I drew polygons in ArcGIS around each of the roadways that lead into the Tahoe Basin, so we could understand how the travel patterns changed into the area seasonally. And I realize that spreadsheets aren't sexy, but the one thing about data, and if you're buying it raw like we like to do as opposed to in a platform, you can specify the time periods that you want. You have your origin and your destination zones here. You have your dates that they've collected the data. So we aggregated it by weekend, which is the WE or weekday. And then trip purpose, time of day, and then a daily count and a monthly count. And then type, which is an internal to internal trip or an internal to external and then external internal, and you get that. The important thing is all of these attributes are variable and can be designed by you as the purchaser. One thing that's important is that not all vendors are alike. And that's the really important takeaway, is that different vendors serve and sell different data. And you have to really understand what you want the data to answer before you make that investment. And in this case, we bought data from a vendor, AirSage, because they're the only vendor that is able to quantify the device user, or in this case, they call it a subscriber class. And so we wanted to know what types of trips were being made by either visitors, long or short term, inbound, outbound commuters, and then people who live in the basin but either work at home as a home worker, or they live in the basin and they work in the basin as a resident worker. And so being able for us to inform our client, the Tahoe Transportation District, how we would best improve their transit network. And of course, the overall multi-mobility in the basin is going to be based on how the different population segments move. So one thing we did, and when you buy an activity density point file, excuse me, I'm going to cough. Sorry, it's really smoky here and I'm being affected by that. Anyway, you can buy origin destination data, which we did, and you saw on the spreadsheet. That comes as a CSV file. But another data set that you can buy is called an activity density point file. And that's the aggregated data of all of the device sightings for a specific time period. So we bought data for February and July, as well as August, because we wanted to understand the differences between wintertime, when people are coming here to ski, and summertime when they're coming here to do everything else. And so using ArcGIS hotspot optimization tool, we were able to identify all those locations where all the people were and the highest concentrations. And in this case, in February, it's on the southeast corridor by Heavenly Mountain Ski Resort, which is, of course, no surprise, because that's the popular ski area in Lake Tahoe. On the southwest shore, you see a red dot over in Emerald Bay, which is interesting because there's nothing to do there except look out on the lake. And it is one of the most beautiful views, and I have shown it in a couple of slides before. What we found was that in February alone, we had 4.9 million visitors just for that 1 month. When we looked at July for the same data, we see that there's a population and an explosion of visitors all over the lake. And what's important here is that there were locations that our client didn't even know were were popular, didn't have any services there, aren't any sidewalks, bikeways, or transit to these locations, to many of them, and that there were 11.8 million visitors in the month of July to Lake Tahoe, and they thought they had 8 to 10 million in the entire year. So what we did is we took those hotspots and I overlaid the locations of popular destinations with transit ridership. We saw that only 1.4% of all trips were made on transit throughout the basin. But most importantly, when I looked at Emerald Bay as one of the most popular destinations, we counted 1.6 million vehicle trips and only 7,400 transit trips. So the low-hanging fruit became focusing on recommendations to improve congestion in this particular location as well as several others. And in the end, our client, came to the realization that using this type of data, location-based data, really enabled them to understand the true magnitude of the total visitors that they have, and that their number was off by 250% because we counted 25.6 million visitors in 2014. And this picture here shows you how you have people walking on these one-lane roads in each direction, parking, walking, and then, of course, impeding the traffic flow and causing all of the congestion. The next project, a transit master plan, this is really about how we integrated data from multiple sources into a dashboard in order to improve our decision making. And this is our landing page. So we created a landing page, and then when you flip through to the dashboard, these are just some screenshots that show you all of the different kinds of data that we were able to bring in together into one platform. So land use data, healthcare, grocery, schools. We broke the city into various regions and neighborhoods and traffic analysis zones. And then we calculated the concentrations of population and then the concentrations of employment. And then we overlaid all of that into existing transit, walk sheds, identified low use stops. But then we also integrated data from APC for transit ridership and location-based services data. And it's all very filterable. And so you can click on in this lower right-hand corner, this is just a population, employment density, excuse me. And so any one of these hexabins, you can click on it and it'll tell you how many people work there, numbers of businesses, ridership, and then numbers of employees. So it helps you by density to focus your data analysis on where it's going to make the most improvement. This is the APC data. Before we put it into this platform, we had over 1,500 maps of the entire city showing all the transit ridership information. So by bringing it into a web-based platform that we created, you can click on any transit stop and see the number of boardings and alightings. You can see the total activity by stop. You can filter this information by time of day, day of week, inbound, outbound. You can even select specific routes and it will redraw for you all of that information. And then we color-coded it so that you could understand the percentage of boardings at each one of these stops visually. So on one map, you get a huge grasp of information, and this is just transit related. We integrated the location-based services data by custom coding the actual TAZ counts and by creating desire lines, and then being able to illustrate the magnitude of population movements throughout the roadway network. This too is very filterable by time of day. You can filter it by whether or not you're looking at a specific region or a sector or a subsector, which is a neighborhood. And then it will just redraw right in front of you the magnitude of populations going in those directions for that additional analysis. This is what we call an adjacency matrix. It's a form of graph thinking. This is all open source code. We have an extensive visualization library. And on our website, on the dashboard, you can actually hover over any one of these squares and it will report the total number of device movements between neighborhoods. So we have origins on the left and destinations on the right. And you can then see the high concentration of populations between specific neighborhoods. And you can focus your your recommendations, and certainly your evaluations on those neighborhoods that have high movements between them. And again, it's also filterable by time of day and day of week. We created a time series data using the GPS point file because that data is aggregated per hour. And so we pulled this in here, and if on the website, it would be live. You can, again, filter by hour of day and then see how the total magnitude of these dots, which actually represents averages of people within the scale, how they're moving throughout the city by any time of day. And these are created by transient points. So you can buy the data aggregated to a home point, a work point, or a transient point. And when you want to create time series analyses, you need to use the transient points. And so this should be, you should see that this is a time series of a specific game day event. And I'm showing how the population moved using those activity density points to the actual game. Now they're inside the game, and then they will disperse after the game. And so based on the aggregated file, you can actually run these very, very simply and understand how the population comes to an event and then leaves an event, which is another thing that we're doing right now for Monmouth County, New Jersey, because it's a heavily tourism-based location and they have huge congestion during these events that impact the local residents. Another project, we did an aerial transportation study for the city of Los Angeles. This is the Hollywood sign, and the Griffith Park is actually a 4,000-acre city park surrounded by neighborhoods. And the people who live in those neighborhoods are highly influential, and they don't like people coming into their neighborhoods to come up and hike through the park and take a picture of themselves in front of the Hollywood sign. So they're trying to solve that congestion by creating an aerial transportation system. And this map shows the 4 different lines that they're looking at. Well, it's 3, but there's a hinge point at the top. The park itself is super topographically challenging, and so putting an aerial system up has to not only navigate over the peaks and valleys, but it has to navigate all of the wires that are in the air from a telecommunications perspective. So my job was to look at a year's worth of location-based data and not only find out how people entered the park and where they went and where the most popular locations were, but times of day, when did they travel, were they locals, were they from far away, and the magnitude of those people coming into the park, where would each and every one of these locations be best suited to do further analysis and cost benefit. So using a year's worth of data, one of the things I created, this is a radar chart, and it basically shows the time of day by season, so it's all aggregated and averaged. And so 6 a.m. on the right, you can see how the population, the numbers swell in terms of the number of visitors coming into the park by hour of day. And so it starts to get pretty busy between 7 and 10 a.m., and then it gets really busy at 6 p.m., and it starts to filter off between 10 and 11 p.m. And so the idea is knowing when the people come, it helps us to understand the magnitude of visitors, because of course they want to determine how much money that they're going to make in order to offset the costs of this transportation solution. But we looked at 30 different ways of this kind of data over the year. And this shows that by using the GPS point file and hotspot tool, we're able to identify the Martinez area and the LA Zoo as the 2 most popular locations to intercept people. And so those are the 2 locations that they're continuing their analysis for the city to build the gondola. And this is just one last project we're just getting started on. And what's interesting about this from a transportation perspective is that there's a pipeline project underway between Edmonton and Vancouver. And the contractors, of which there are several, are building in areas that are impacting the travel flow on the roadway. And our goal is to use data from 3 different sources in order to make sure that the contractors do not impede or delay travel longer than 20 minutes per district. And so we're using location-based data to analyze the 2019 travel patterns so that we can have a baseline, and then Bluetooth sensors and Google APIs, and the Google is collecting data every hour, every day for the next 3 years, so that we can then produce automated reports and actually address a traffic problem or a poor implementing contractor in the field right away, because the agreement was that there would not be a travel delay of longer than 20 minutes. So this is kind of the first time we've ever aggregated all these different types of data into one travel delay study, but we're optimistic that we're going to be able to successfully deliver on behalf of the BC MODI, so that the contractors are all fulfilling their obligations as part of the construction project. So now I'm going to turn it over to Stephen.
Thanks, Cynthia. So what I'm going to run over relatively quickly is some of the ways to incorporate this data in to help with the decision that we've been finding to help with the decision-making process, and some of the examples we have. And so the first part is a quick run over of a multiple account evaluation structure. For those that are less familiar, I expect there's some general familiarity out there. And then 3 different ways that the data can be incorporated into an evaluation, using origin destination data, using network density or demand area data, and then using what I call an area destination data set. So Cynthia, the next slide, please. So the multiple account evaluation or multiple criteria analysis is a tool by many different names, but if you're working towards a project selection and it has a top-end account that really indicates those things, that those categories that matter in the evaluation process, you come up with a few ways to measure that account, and then you come up with specific metrics for that criteria. The data, often people will think to put the data on the front end. They say we have this high quality data and therefore that's what we have to measure, but the data, especially as it's high quality, can be used in a variety of different ways across the metrics to increase the understanding. Next slide, please, Cynthia. So this is an example of the process for multiple account evaluation. You have a full set of projects, and when you structure these out, you'll have multimodal projects, infrastructure projects at varying ranges and costs. And at the end, you need a rank set of projects that's measuring apples to apples, even when you're dealing with a whole fruit bowl. So conduct a fatal flaw review, and then you look at the qualifying projects, run it through the land use, and then you run it through your multiple account evaluation. And examples of accounts you may have run into on previous ones are urban integration, where you'd run into things like developability, TOD, constructability, whether or not it can be built, which tends to be pretty important, safety, cost, stakeholder interest, and transportation. And then and there's a range of others, but the transportation is a very heavy component of where this data is used, and those are the ones that I'm going to hit on in particular over the next 3 examples. The next slide, please, Cynthia. So in this example, which is what I was calling the origin destination problem, it's where you have a very strong data set, and by a strong data set, I mean data that can be relied on and is very granular, where you have a very good understanding of where people are starting their trips and ending their trips, even if it's not by the mode you're evaluating. So you can come up with corridors, and this came from the dashboard that Cynthia put up earlier, and equally that the device count dashboard that Cynthia had up with the bricks and the concentration of colors also informed this. And what it allows you to do is say, this is the trips these are the trips people are making now, these are the trips people are making now by our mode, and you can start to create corridors where you can visualize both the routes people are taking, but also where those congestion points are, so you can really capitalize on specific point infrastructure improvements and prioritize components of a larger project instead of just prioritizing the larger thing. A lot of this comes down to not only good data making good decisions, but it's also good data understood making better decisions. And so the visualization component of that is critical on that piece. Next slide, please. So 2 ways that this was used on the transit master plan. The first is by creating corridors that connect a direct origin and destination pairing, and you come up with these, you can come up with these routing alignments that become truly competitive with modes that the transit system wasn't originally competitive with. But then leveraging the strength of transit in providing transfers, you create a number of origin destination pairings that are available through one transfer, and you can optimize the route or evaluate the route and the little point infrastructure that will bring that to the forefront. And that one transfer, when you expand it even to include the first last mile bubble, you can really start to encapsulate the entire city or region you're studying. Next slide, please. So the network density is one where you, if you think to the gondola example, is one where you have a very good understanding of areas where you have high performance or high activity now that you need to connect together. And this is from an active modes project where we were starting to take those high quality areas and come up with a network density plus redundancy that allows you to connect the components together. So we wanted a redundancy that served for users of a variety of requiring a variety of comfort levels, and you can prioritize redundancy, and then you can evaluate those other accounts to say which part of that network needs to be built out first. And by using the data to have a very good understanding where those darkest blue areas are, you can draw the strongest connections that will allow the blue to connect together, and you end up with strong corridors. Next slide, please, Cynthia. And so this is the area destination problem. So this commonly it's a first last mile transit access, active and safe routes to school. Have used a similar approach. This is a transit example here, and the recreational or the sports can use a similar one where you have a strong magnetic draw that draws from the neighborhood in general. And so what you can do is by understanding the components that make up that neighborhood through fixed variables, you can compare it to another neighborhood for which you have strong data or for which you have a strong understanding. So in the transit example, you can use like any North American city with a similar transit structure, and you can find out and you can use their first last mile to deconstruct how it should be operating, and you can either help prioritize infrastructure to get it operating that way or help the development inform the direction going forward. So if you could go to the next slide, please, Cynthia. This is an example of that transit project, and you can see how the different neighborhoods you expect. For example, the orange is walking. You anticipate a different level of pedestrian support with each one. So if you're in an urban commercial environment, but you're finding that you're getting a suburban retail mode shift by which you have a very low walk rate, to that, you can start to look for the barriers that are creating that. Or if you're introducing a new transit line or a new level of transit service, what you can say is you can say, okay, we expect that this is going to behave like a medium density urban neighborhood, and you can invest your infrastructure appropriately, and it allows you to look at a sidewalk and transit infrastructure similarly. This particular example looked at walking, cycling, transit to transit access, auto drop off, and park and ride all equivalently, and allowed us to prioritize off each of those examples. Okay, thank you, Cynthia. You can take over again.
Okay, well, thank you, everybody, and we're ready for questions. And if you'd like, I'm going to stop sharing and turn it over to you, Josh.
Perfect. Thank you very much, Cynthia and Stephen. So much information there. It's yeah, a lot of really interesting project examples, and look forward to the discussion. Once again, I'll just encourage folks to type questions that you have into the chat window, or even just to indicate that you'd like to ask a question, and then we can turn the microphone over to you. But to start, Cynthia, I have two questions for you from Zhang Liu, and the first is related to the purchasing of the traffic data. So Zhang asks, after purchasing traffic data, did your team conduct any field data or other data source calibration to confirm the purchased data was reliable?
Good question. Yes, one of the things that I like to do is I like to map the data first, and I find that's one reason why I like to buy the data in its raw format. If I'm using it entirely within a platform like software as a service, which you can buy, I find it a little bit more wanting you to rely on what they put on the screen. And so I like to sort of push my sleeves up and get down and dirty into the data, and I like to map it and query it and look at it in relation to other data sources. In order to convince our client in the Tahoe Transportation Basin, for example, you can imagine that when they think that they have 8 to 10 million annual visitors, and you have 5 governmental agencies and 2 DOTs and state and federal land management agencies, when you as a consultant are telling them, no, I'm sorry, but that number is wrong, and it's not only wrong, it's off by a lot, that kind of message doesn't go over very well. And so we naturally had to find a way to justify that the number was in fact correct. And it turns out my traffic engineer here in my office, we use, NDOT and Caltrans data all the time. And so by looking at another data set, we were able to show our client and all of our stakeholders that the traffic counting data actually corroborated the location-based services data, but the two sets independently. From a traffic perspective, if you only looked at the data the way that you typically do, you would have thought that their data was right. But when you introduced another data point, you sort of expanded the ability to see the data in a much broader perspective, and it totally corroborated it. But the one way that I like to do I like to map it first and test my instincts and compare it to the locations of other information that is readily available. Is the data making sense? Are we seeing concentrations of people in locations that we would expect, or are we not? Because I have purchased data before and done that and found that there was a problem and had to send it back and have them re-aggregate it and send it back to us. So it's always good to do that.
That's terrific, Cynthia. Maybe actually building on that a little bit, and I know this is something that you and I have talked about a little bit before, and you also highlighted sort of at a broad level within the presentation. But I'm wondering if you could speak a little bit further about the different potential sources that folks might be thinking of for purchasing the data sets, and perhaps within that considerations for how different modes of transportation are accounted for within the data that you're analyzing.
Okay, sure. Well, there are obviously several vendors, and there are lots more people getting into this space all the time. The vendor that's been selling location-based services data longer than anybody is AirSage. They've been doing this for almost 19 years. And Streetlight used to buy AirSage's data before they formed a partnership with INRIX. And they're only getting part of their data from INRIX. But a long time ago, when all of the data was cellular-based, it was pretty much AirSage, and there's a couple in Canada, but for us in North America, it was AirSage. And they are not in the business of necessarily selling it software as a service, although they're moving in that direction. But Streetlight has certainly filled that niche, and they are in the process of trying to deliver on the mode split variables, because that's what a lot of agencies want to see is, okay, we understand there's 100,000 people going down this road every day, but who's on a bus and who's in a car and who's on a bike and who's a ped? And I get that. And all of the vendors are doing their very best. And as the accuracy levels have gone from 100 to 30, now down to 3 meters, which is the accuracy level I always buy, 3 meters, you can really start to differentiate. But in congested areas, it is much more difficult to do so. And so even Streetlight, who is probably leading the way in saying and demonstrating that they can, in fact, share with you a reliable mode share output, it really is predicated upon the local jurisdictions to provide them with the necessary input for them to calibrate their models. So if you as a community don't have reliable bike, ped, transit, which is easy, but bike and ped, for example, data, then the data you get from Streetlight or another vendor might also be a little bit unreliable. I'm not saying it's going to be, but it might be, because the first thing that they ask is, what do you have for us to use in our models? That's the same thing too with Remix. They are a vendor who sells location-based services data, and they actually built something similar to what we built before, where they're integrating other kinds of data sources like land use and zoning and other modes. But it's really predicated upon the data that you have as a community to share with them. Otherwise, if your community isn't collecting that data, then that should be a really high priority, even using graduate students or some other form of data collection, because it is really about mode share and in expanding the mode options, which is predicated upon understanding how the various modes operate together and the magnitude of the ridership on each of those modes.
Awesome. Thank you, Cynthia, for such a thorough overview. We have another question from Zhang here, specifically about the dashboard that you're showing some screenshots of. And Zhang was interested, I think, in how this was developed and specific help from IT, and if there's any other online links to learn more about the specific dashboard. And I might add on to that as well, just commenting on your experience of using dashboards as part of projects that you've done, and how they've maybe been helpful to the clients that you've worked with. So how did you develop the dashboard, and where have you seen there to be the most benefit with using them on your projects?
Okay. So first question, yes, our Stantec team developed it exclusively. We were not all in Nevada. We have people that I collaborated with in New Zealand and Toronto, here in Reno. It's really a collaborative effort. We have a whole team of data scientists in Stantec, and the dashboard for that particular project was, in fact, a combination of Stantec funding through a research grant that I applied for and received. So Stantec paid for the development of the dashboard, and then our client paid for the analysis of the APC data. And when we had 1,500 maps, it was my suggestion that we put this online, because nobody's going to look through 1,500 maps, even though there is a data library and it's gridded out and you can find it. It's just too cumbersome. But in order to really understand, like, the importance of what's going on at that street level, you need to have the maps at that scale in order to do it. And that's why we came up with this idea of this dashboard. And that's why we built it, so that it has multiple types of data integrated into it. And we've used it on on this project that we were talking about, this transit master plan, and we're using it on the BC MOTI project for the travel delay study. And it's really, there are lots of, it's a combination of, you know, SQL Server, visual libraries, just a bunch of, like R-Shiny is a really popular visualization tool. And so a lot of the visualizations are open source code, but the coding of taking polygon aggregated counts and creating desire lines is really a data science tool or step, and you have to really understand data science in order to be able to do that. Does that answer the question, Josh?
Yeah, I think that's great. Thank you very much, Cynthia. We have another question here from Brenda, and one thing I wanted to just highlight before I pass that question over to you, Cynthia, just in case some folks had logged on without, you know, seeing the reminder email we had sent out this morning, and some of my notes in the chat window here, that, you know, we had initially planned this this session to go through, you know, very similar content to what we've described, but specifically within the context of the Winnipeg Transit Master Plan. And although this was something that we had confirmed that it would be okay to proceed with, just given the more public nature of this presentation, we've had to postpone that specific content until the Transit Master Plan has been approved. So appreciate everybody's understanding of our need to adapt the presentation and explore this content in a bit of a different format, and just wanted to cover that off for folks who are here and were maybe just wondering about that. But I'll transition over to Brenda's question now. And Brenda, thank you for sharing this. She was interested in the Trans Mountain study, I think. So the Edmonton to Vancouver project, the cost of the study must be quite significant for the amount of work. She's curious about the business case and how the project was sold to the owner, and what specific benefits did they see that offset the cost of this study? Did it result in monetary savings, or was it simply done as an enforcement tool? And Cynthia, if I could as well sort of add to that, I think it would be helpful to maybe just reference sort of in general sort of the magnitude of cost for even just for purchasing the data for some of these studies, and where you're seeing the benefits are for the clients that are choosing to go forward with them. But yeah, first let's walk through Brenda's question there.
Okay, sure. Thank you for the question, Brenda. Well, the cost isn't actually that significant, as you might think. The location-based services data is about $75,000. You know, it's really the Google API and the sensors, because we bought the sensors, and we bought 10 pair. And so we're moving them all the time. And so the cost of the construction of the pipeline is like, I don't know, hundreds and hundreds and hundreds of millions of dollars. And so the fact that they're investing $1 million to make sure that the communities that are impacted anywhere along this particular roadway network and construction are not significantly delayed because of the construction activities, the client saw this as a real benefit. The client is also very tech savvy, and he was really interested in using digital data, location-based services for the baseline, and then of course Google API data that we're collecting and scripting and analyzing on a daily basis to be able to tell, you know, the community and of course the civic leaders that we are using the most cutting-edge technology to ensure that there is no travel delay. So in some respects it is an enforcement tool, but in other respects, it's really just to make sure that they can honestly say we're using every bit of technology available now in order to ensure that this project, which will be a 4-year construction project, doesn't negatively impact the communities that are experiencing construction right near the road or a bit off the road, but has trucks moving in and off the road in order to access the construction. And so it's really just taking advantage of the technology that's available to ensure that the communities are protected, because we give them daily updates, and then they can, and we're creating a dashboard right now. We're in the process of creating the dashboard right now so that the client can access it at any time and see what the travel delays are and ensure that everybody is compliant with the agreement of no longer than 20 minutes. Does that answer the question, Josh?
Yeah, that's great, Cynthia. And I'd just be curious maybe to build on that just a little bit regarding sort of how you, I guess, are exploring the value of the cell phone based data with even different types of clients, and where they're sort of seeing the different benefits from maybe the one that you described here with Trans Mountain.
Okay, well, like I said kind of in the presentation, there's lots and lots of different types of data that's out there, and it's really having a solid understanding of what you can do with the data and what questions the data can answer for you, because it really is just one more data point. It's not necessarily the answer. This type of data isn't the answer for everybody, but it does help when you can find an origin and a destination of a trip, which is sort of old school. Okay, we know this, we know the O's and the D's just based on travel demand modeling. But now if you can understand that O and D was created or was made by somebody who works at home and happens to be in a particular age level, income level, sex, all those other kinds of metrics. Now you can really begin to more fully understand why a population is moving where they move and what kinds of solutions you can implement in order to mitigate all these population movements, or more importantly, just improve the overall quality of life. And that's one of the things that Stephen does is, we collectively take all this data and Stephen runs it through his MAE process and comes up with a lot of different options in order for the client to figure out which works best for them. But it's just getting back to fully understanding the data that's available, the sample sizes, the accuracy levels, knowing that it's a quality vendor, and knowing that they're capable of answering or at least delivering data that enable you to answer the questions that your client needs. And that's kind of the most important thing, is because they'll sell you. They're in the business of selling data. So don't necessarily believe everything that they say they can do. Really question them on, okay, you say you can do mode split. Okay, what is that proportion? What are those sample sizes? What are the accuracy levels? What are some of the pitfalls? How are we going to address A, B, and C? Because it's a vendor. They want you to buy their product. And so you really need to just be as informed about their product as you can be, so that you can ask those intelligent questions in order to get the right product for you and your client.
Wonderful. Thank you very much, Cynthia. I think that provides a nice close to the session here. Again, want to provide a big thank you to both Cynthia and Stephen for putting their presentation together for us today to better understand how location-based data can be used to inform transportation decision making, and how the MAE process can be used in conjunction with it. So thank you, Cynthia and Stephen. And thank you to everyone for attending today, and again for your patience and adaptability with the presentation topic. And stay safe out there, and we'll look forward to connecting with you all again soon.